Hey guys, Mr. Zigner again. We're going to look at surface area and volume of similar solids today. So what are similar solids? Well, here I listed a few examples, but the ones that are similar are ones that have the same shape and have proportional corresponding dimensions. Well, we'll talk about that part as we go through this video. Here we go. All right, well, here's an example. They're asking us which cylinder is similar to cylinder A. Well, here's cylinder A. Here's B and C. So we're supposed to figure out which one of these is similar to A. Well, what they've done is they've set up a proportion. So a proportion is two ratios that we try to set equal to each other. And if they are equal, we call it proportional. And if they're not, well, they're called not proportional. Alrighty. So cylinder A, what we want to do is set up a ratio. Here's how they set this one up. They took the height of cylinder A over the height of cylinder B. All right, so the height of cylinder A is 4. The height of cylinder B is 3. So they've made this fraction-looking ratio called 4/3. Then they set up the radius of A over the radius of B. Notice they keep the A on top and the B on the bottom. That has to hold true for both ratios. So the radius of A was 6. The radius of B is 5. Now, does 4 over 3 equal 6 over 5? Well, absolutely not. And here's one way of checking that. If we do what I sometimes would call cross products, so what I mean by that is multiply 3 times 6. Well, 3 times 6 is 18. And then we go 5 times 4, and 5 times 4 is 20. That's a quick way of checking to see if your two fractions, or in this case, ratios, are equal. And in this case, they're not. So, nope, cylinder A is not proportional to cylinder B. Let's try A and C. All right, so again, the height of A is 4. The height of C is 5. So we have our first ratio of 4 over 5. The radius of A is 6, and the radius of C is 7.5. Now, that's a little more intimidating of a fraction, but it's not too hard to do our cross products again. So once again, we go 5 times 6. Well, 5 times 6 is 30. And 7.5 times 4. Well, you could bring up a calculator. I could do that. But 7.5 times 2 is 15. And if we double that again, we get 30. But here, we'll just show it to you on the calculator. So 4 times 7.5. And yep, there's that 30. Okay, so the cylinder A and cylinder C are the ones that are proportional. They are similar to each other. All right, here's the first one we have to do ourselves. Are these two solids similar? Well, let's get to work setting up our ratio. Now I'm going to pick, let's see, we call this a slant height right here, this outside measurement on this cone. So I'm going to put the slant height of the first one, the first cone, that's 13, over the slant height of the second one. So that's 5. All righty. Now the second one has to be set up the same way. Well, this internal height on the cone is 12, and the internal height of this cone is 4. All right, so once again, let's try those cross products that I mentioned earlier. 5 times 12, well, 5 times 12 is 60. Is 13 times 4 60? No, 13 times 4 is actually 52. So nope, it does not look like these are solid. I'm sorry, not solid. They're not similar. All righty, moving on. All right, same directions. Are these two solids similar? Well, let's set up our proportion. Now I can pick whichever set of numbers I want here. How about we'll start with the height. The height of the first one is 10, and let's put that over the height of the second one. So that's 15. So 10 over 15. Now finish my proportion with a different ratio. How about the front width measurement here on this one, on the first one, 4, over that same measurement on the second one, 6. All right, are these ratios equal to each other? Well, let's try it out. 15 times 4. Well, 15 times 4 is 60. And 6 times 10, well, what do you know? That's also 60. I'm curious though, let me try a different set of numbers to make sure it remains equal. Change colors for this one. How about this depth measurement of 2 over the same measurement on the larger one, 3? Does that equal, no, which one should I pick? How about we do the height again? So the height of the first one, 10, over the height of the second one, 15. Do those cross products still equal each other? 3 times 10, 30, 15 times 2, also 30. Oh, so these are similar. And we have our work here proving that our proportions are equal. I'm sorry, our two ratios are equal, forming a proportion. All right, moving on. Oh, we have something new. So now we're actually finding missing measures in our similar solids. Okay, so they're already telling us the solids are similar. We don't have to figure that part out. Instead, we have to find a missing measurement. We have to find the missing slant height. Here it is. So we've got to figure out how long this is. Now, this is just an example, but let's walk through it. Let's look at this proportion they set up. So they took the radius of the first one, x, so there's that 5, over the radius of cone y, which was 7. Okay, good. And that's supposed to equal the slant height of the first one, 13, over the slant height of the second one, and they're calling that L. All right. Now they did their cross products. 5 times L is 5L. 7 times 13, yep, that is 91. How we check their math here, though? Divide by 5 to get that letter L by itself is 91 divided by 5, 18.2. 91 divided by 5. Yeah, there we go. There's that 18.2. So there we go. That's how you figure out that missing dimension on this one cone. All right, let's see if we can do one ourselves. Okay, they gave us 2 pyramids to work with. So find the missing dimensions. So there's 2 that are missing. Yep, we're missing the letter S and also L. So we have a couple problems to do. Let's get to work. Alrighty, so let's see. What could I do for my first ratio? Oh, here we go. How about the height of the first pyramid, 4, over the height of the second pyramid, 3? That's that internal height in the middle of the pyramid. All right, so now let's see here. We have to figure out this S. So how about we take that same measurement on the first pyramid over this missing one, S. Sorry, my S's look a little bit like a 5 there. Okay, let's try our cross products. So 3 times 6, well, that's 18. And 4 times S is 4S. Okay, 4 doesn't go into 18s, and I don't want this video to last forever, so let's just use a calculator to find that amount. So 18 divided by 4, well, that's 4.5. So it looks like, S is equal to 4.5. Now let's get our measurement. Now this was feet, but the one I'm working on over here is in centimeters. So this would be 4.5 centimeters for the letter S right here. Okay, we still need to get this slant height. Let's change colors for this one. Okay, I think we'll stick with the internal height of the first pyramid over the internal height of the second pyramid. So there's that 3. So using the same ratio, but now to solve for a different measurement, in this case, the slant height. So let's see, we have a slant height of 5 on the first one over a slant height of, oh, right, this is the thing we're trying to figure out. So L, I'll try to do a nice little cursive L there. Okay, let's do our cross products. 3 times 5 is 15. 4 times L is 4L. Okay, divide by 4. That gets the L all by itself. And again, 15 is not evenly divisible by 4. And to speed things along, we'll jump to our calculator. 15 divided by 4 is 3.75. 3.75. Now again, let's get that correct measurement. We were finding the slant height on this one, and this pyramid is measured in centimeters. Okay, so our front measurement here was 4.5, and our slant height was 3.75, both in centimeters. Okay, next. Okay, we have two cones. Let's set up our proportion. All right, let's see. What do we have to figure out? Oh, we have to figure out the height of this particular cone. So here we go. How about this radius? The radius of the first one over the radius of the second one. So 3 over 1, that would equal this internal height of the cone. That's 1.5 of the first one over the internal height of the second one. And that's the thing we're trying to figure out. So there we go, h. Alrighty, cross products. So 1 times 1.5 is 1.5. 3 times h is, well, 3h. Okay, let's get that h by itself. We'll divide by 3. Cancels out the 3's. And we have h equaling, well, 1.5 over 3, but I'm not supposed to have a decimal in a fraction. What could I do? What could I do? How about we multiply the top and bottom by 2? Let's see, what does that turn into? Well, 3 times 2 on the bottom is 6, and 1.5 times 2 would be 3. So there we go, 3 over 6. Oh, wait a minute. 3 over 6 can simplify to 1/2. So there we go. It looks like it's 1/2 of a centimeter. Oh dear, I noticed one more thing. You see right here, they gave us a number in decimal form. Here's a little thing to keep in mind. When you're given decimals in a problem, really you're supposed to answer with a decimal. Now I just answered with a fraction. So in case you had a fussy math teacher, let's just make sure our answer is also in decimal form. So 1/2 as a decimal would be 0.5 and centimeters. Here, I can just show that to you real quick. 1 divided by 2. So there's our 0.5. Okay, there we go. So our internal height of this particular cone is 0.5 centimeters. Let's see what we have next. So now we have a new formula here. So when we're dealing with the surface area of similar solids, okay, when two solids are similar, and here's several examples of solids, the ratio of their surface areas, okay, so you make a ratio of one surface area over the other, is equal to the square. So we're raising to the second power of the ratio of their corresponding linear measurements. Sounds a little scary. What they mean is, well, in this case, for these two cylinders, they're saying the ratio of this one's radius versus this one's radius. So like that radius would be on top, the other radius would be on the bottom, and then we square those numbers. All right, well, if that sounds a little intimidating, don't worry, we're going to work through that. Here we go. So I brought that formula over. I didn't want to forget it. Let's get to work. So we're supposed to find the surface area of the shaded solid. Okay, so we don't know the surface area of this one yet. Okay, well, let's try to set up this proportion. Okay, the surface area of the first one, okay, well, that's 198 over the surface area of the other one. Well, that's the thing we don't know. How about we use the letter S for that? Again, sorry, my S's look a little bit like a 5 there. Now that's equal to the measurements that they give us, these linear measurements. Oh, here we go. So they gave us a 6 for the first one and an 8 for the second one. Okay, but that's not it. No, we're going to square that. So put that in parentheses and square it. All right, let's start simplifying that. Well, there's nothing I can do over here, so I'm just going to bring this down. 198 over S, and that equals, well, 6 squared is 36, and 8 squared is 64. Okay, we're getting some big numbers here. I believe we're going to use the calculator in a little bit. But first of all, let's do our cross product. So we have 36 times S is 36S. And 198 times 64. Haha, time for the calculator. 198 times 64. And that is 12,672. Did I write that correctly? Yes, I did. Okay, so now if we divide by 36, that cancels out. And we have S equaling, well, whatever that equals. So we're going to divide our 12,672 by 36. 12,672 divided by 36. 352. So 352. Now, what are we measuring in? So this one's surface area would be measured in meters. Now, since it's surface area, that would be meters squared, right? Surface area's answer would always be in whatever unit we're measuring in squared. All right, there we go. So the surface area of this larger shaded shape is 352 square meters. All right, moving on. Another formula. So now instead of surface area, we're dealing with volume of similar solids. So here we go. When the two solids are similar, so we're being told these two are similar, the ratio of their volumes, okay, so the volume of the first one over the volume of the second one is equal to the cube of the ratio, there's our ratio, of their corresponding linear measurements. So it looks like in this case they used the radius of the first and the radius of the second. All right, let's give one a try. Again, I brought that formula over so we could actually remember how to set up this particular proportion. All right, here we go. So let's see here. How about we put the volume of our shaded figure? Okay, that's the thing we don't know. So, let's use V for volume. Okay, the volume of our first one over the volume of the second one, so that was 54, okay, is equal to our, how did they word that? The ratio of the corresponding linear measures. All right, so let's get our ratio going. The cube of the ratio of our linear measures. So this first shaded figure, because I'm putting the shaded figure on top of my ratio, is 8. And that corresponding side on the smaller one is a 3. All right. So let's just start simplifying this. Well, there's nothing I can do with V over 54. But over here, we have 8 to the third and 3 to the third. Now I know what those are, but why don't we just bring the calculator up for those? So 8 to the third power is 512. Just want you to be able to see where I'm getting my numbers from. And 3 to the third power, do you know what that is? I think it's 27. 3 to the third, yep, is 27. Get that fixed there. There we go. All right, so, oh my goodness, I see an easy way to solve this. Do you see it? I think I'm going to still use my cross products, but I'm going to come back later at the end of the video to show you an easier way to solve this one. I just noticed something. I'm wondering if you notice it also. But first of all, let's solve it the traditional way. So our cross products would get us, well, 54 times 512. 54 times 512 is 27,648. 27,648. On this side, 27 times V would be, well, 27V. All righty. But I need to know what the V is. So let's divide out this 27. That would cancel it out. Divide the other side by the same thing. All right. Now, again, that's definitely a calculator kind of a problem. So 27,648 divided by 27. 1,024. Okay, so it looks like the volume of our shaded figure is 1,024. Now it's measured in millimeters, so that would be millimeters cubed. Right. So whenever you're finding volume, those answers would be in cubic, a cubic measurement, so to the third power. Now, coming back, do you see the other way we could have solved it? Do you see it? There's actually a much easier way to have arrived at that answer. Right here, I noticed that 27 times 2 is 54. Now, if I multiply the bottom of the fraction by 2, I also could multiply the top of the fraction by 2. And guess what 512 times 2 actually is? Yep, 1,024. Now, that won't always happen, but it did happen to work in this one. Alrighty. Well, that brings us to the end of our time. I hope this video was helpful. And as you can see, my teacher's website here, you're welcome to check that out. Um, Feel free to subscribe for more videos. Click that like, that's always helpful. And we'll catch up with you next time. Thanks a lot. Bye bye.